Okay, good. So since we all completed, then I will start the part one. So the part one focused on the following: building a basic CMake project, learn some effect about from the compile options, and I will provide some basics about the so-called address sanitizer and some tips for using VS Code plugins. Okay, so this is an overview of CMake. So this lecture tutorial is about the CMake, and then why do we want to use CMake, and what is CMake? So CMake is a build generator for build systems, such as for example, this is a graph showing the the workflow of the CMake and the make file. So when you completed your source code in C or C++, you can either write a make file so that you can get the source file compiled and then produce an executable. Or you can use CMake and writing the so-called CMake lists .txt to generate this make file. And then you type make to produce the final executable program. So why do we use CMake? Because it's a it can be used across different platforms like Windows, Linux, and embedded devices. On the other hand, compared with the actual build system, the actual build system such as Make, the CMake is easier for us to learn. So basically, it's an encapsulation or higher layer program that help us to generate the make file. And the make file itself is more abstract and complicated than CMake, while CMake is close to the programming language such as Python we use every day. So it will be easier for us to learn, and we can build a complicated or automatic build system upon CMake. So aside from the difference between CMake and Make, some of you working in the field of robotics will come across the so-called CMake. So when you use ROS packages, you often use CMake to build your project. So the difference between the CMake and the CMake used in ROS is that the CMake is another higher layer encapsulation of some programs plus CMake. So you can view that this is a program, CMake. It will set up some environment for you first. For example, it will build the working directory, such as develop the directories in your working directory. And it will scan all the source code and the CMake list, and will run the CMake for you. So that is the difference between CMake and CMake. So when you are familiar with CMake, then you will easily will become easier for you to debug and use CMake as well. Okay, so any questions so far about the basic definitions? Anyone? Everybody good?
I have one.
Yeah, sure. Go ahead.
Why not directly write CMake instead of using CMake?
Yeah, so I like I explained before. Yeah. So I explained it. So the CMake is higher level generator build systems, while Makefile is a low level actually build system. So Makefile is actually a more complicated and abstract. You will see the Makefile generated by the CMake in later practice. Then you will see how there will see a clear difference between these tools. And CMake is a higher level build generator. It works like a Python for us to easy to learn and use, and also produce a more complicated and more advanced build system.
And is there anything that Make can do but CMake can't?
Right now, the CMake is only a generator, so these are two different types of concept. Right? So CMake here is only to use to generate a make file. So then you just run this make command to execute this make file to generate executable. So so we can hardly say that if there's anything that a CMake can do and make cannot do, because they belong to different levels of development.
Okay, got it. Thank you.
Okay, everybody good? Okay. So then we will just proceed to the part where now we're building your own project. So I believe that you all installed VS Code, and then you open up your VS Code and build a working directory here. This is in this slide. So in your working directory, you should add several subdirectories. The first two are build the debug directory and build a release directory. So you have a debug version and a release version executable be put into this folder. And a SRC directory, which contains the source file of your program. And then you create a root CMake list.txt file. This is your main CMake list file, which is gonna be used for producing the build system. Finally, there are 4 shell scripts added. These 4 shell scripts for configuring and building. So right now you just create this shell script without adding any content here. Just make sure the names are correct. So if you have already so if you are done, so please let me know.
We manually create the folder.
Yes, so manually create a folder which contains those subdirectories and shell scripts and the CMake lists file.
Hello. Is this file properly set up if I just download your files from the GitHub, like from the previous slide?
Yes, you can download it from the GitHub, but I would recommend you do it manually, just
Okay.
for a better understanding of this, all the concepts and yeah.
And everything, all of these files are just like blank for now, right? Because we don't get to see the contents of the files from this screenshot.
No, you just leave the empty directory and empty files. So I will show you how to add content in later slides.
Okay.
Okay.
just confirming. Okay. Okay, just confirm. Do you need the are these folders outside of the red box?
So what's that? What is the question?
Do we need to create the folders outside the red box?
Yeah. Oh yes, you need to create a higher like a working folder, a folder that contains all the sub folders and the files. Is that your question?
So, I mean, do we need like .vs code? One second.
Okay, I think I've created all the empty
Right.
files.
Okay. So what about others? Have you all done? What about Chao? What about you? Okay. Uh, yeah, so like Frank mentioned, you can actually click this link to build the source code. So this source code is can you actually see my screen now? Source code is in my GitHub, so you can build a source code just by clicking this link and to build all the contents. Okay. So after you create this all the subdirectory and the corresponding files, in the root CMake list.txt, and then type the following. So the first one is CMake minimum requirement. It's a minimum required. So it specifies your CMake version. Right now, we just use 3.15, and then your project name. You can type whatever name you want. So here I just use CMake tutorial, and your versions and the language supported. And then you specify this C++ standard as 17. Then type this so-called message. This message is command is like a print command in Python. It will basically just print out this CMake build type for you. And then finally, just type this if statement here. So the if statement is going to set your compile flags based on the build type you specified later in this CMake command. So it compares the content in this CMake build type with a string. For example, if it determines that it is equal to debug, and it will load the debug options to the compile flags. And if it's not debugged, and then we'll load this sort of release compile flags into the compile option. So if you think this line 11 is too long, you can just directly copy this line from the source code, so saves you some time.
What is the default value for the CMake build type?
I will show you later. It's input argument that you when you are using the CMake command. So it's later. So I will explain in later slides. Just here you just treat it as a global variable in this CMake. So if you are done, just let me know.
Done.
Okay, what about you, Cindy?
I
Okay, so yeah, Frank, have you done, or you have some if you have some problems?
I just I'm also done. Yeah.
Okay. What about you, Shangyi? Yeah. So here are some detailed explanations about what you just type in. So those are very easy to understand, and just make versions, project names, and to display what you have entered, put as argument in the CMake. And this part is the debug file, debug options you put in the build system. So for example, if you put dash wall w all here, it tells you tells the compiler to show all the warnings. And for this dash w error, it actually raises all warnings to errors. So it forces you to write a program that has no error, no warnings as well. This -0 here means that no optimization is done. Compile optimization is done for debug mode, and all this following terms are for debug informations, such as this -G is used for GDB debugging, which I will introduce in next module. And the last two are for address sanitizers, for it to determine whether there is a memory problem in your code. So if you specify the build type as debug, it will add many flags in the compile options. But if you specify the build type as release, all these compile options are gone, and this will only a compile optimization is added. -03 is added for better performance. So here the idea is that if we want to debug the program, we need to show as many information as possible, and we don't care about the performance. And after we have debug all the problems and we think the program is fine, and then we recompile it into a release mode and get rid of all this compile flags, because it will create an overhead in our program. And we change the flag to the maximum optimization possible for us for the build system. So if you are interested in understanding more about those compile flags, you can always click this link and to read more about this the meaning of all those terms of this tutorial. Okay, here are some detailed explanations. So you don't have to worry about all the details. You just know that there's a -0. There's no optimization. It's optimized, but it's the compile time is going to be shorter. And if you specify it as -03, it's optimized for speed. Okay, now then your next task is to write the first piece of code in C++. So then first you navigate to your src directory. So to this directory you just created, this source directory. Create a test1.cpp file. This is your first program, and then in the program you type the following. So basically it's just a program, and it will create a vector and put some numbers in it, and we print it out.
I am done typing.
Good. Down. Okay.
Down.
Good. Okay. Next is in this your root CMake list.txt, and you can just type the following. So under the compile options, now what we're now going to do is to add this the source file and add a target. So we build this target based on the source file you just typed. So here is you use this add executable command. The target name is specified as test1, the same as your file name, and the file directory is src. Then is test1.cpp. And here we need to link the target with a what's called an address sanitizer library, which is specified in the compile options. And then finally the compile options we just specified as GNU flags from 919 to 921.
Done.
Yeah, same. Done.
Okay, good. So then the next step is to so in your shell script you just created, and in the config debug.sh you type this following command. So CMake, just this one line. Don't type both lines. This one line. The CMake -s. There's a period here. Don't miss this one. And -b, and then you specify the build directory as build debug. And then there is the, you can see this -d means that we want to enter a variable together with our CMake command. So this specify our build type. So -d CMake build type equals to debug for this debug.sh. And for config release.sh, the difference is the build folder is